Good day. We are Group 4 from Class Physics 6. So today we will be presenting about question 4, which is the non-ferrous metal separator relating to the concept of electromagnetic induction. So, do you guys know what is a non-ferrous metal separator?
What is the purpose of a non-ferrous metal separator? The non-ferrous metal separator, also known as the eddy current separator, is an advanced separator that excellently separates non-ferrous metals like aluminum, copper, brass from inert materials like glass, stones, plastic, wood, and eliminates the smallest parts of the ferrous metals left from the sorting with magnetic separator. It presents a great benefit. You can have all these three different types of materials purely sorted directly into separate containers. Difference between ferrous and non-ferrous metals. The definition of ferrous metals are metals that have ferrum, more commonly known as iron, in their composition. Non-ferrous metals, on the other hand, have little to no iron. The physical characteristics of ferrous metals. They have physical differences between the two metals. Ferrous metals are more durable. They have high tensile strength and are more commonly used in construction than non-ferrous metals for this reason. Ferrous metals also have high melting points. Ferrous metals are also easily magnetized and demagnetized due to their iron composition. This makes them useful as electromagnets, temporary magnets. Soft iron cores are used in transformers for magnetic induction. On the other hand, non-ferrous metals are metals without iron, which means they are not magnetic. Non-ferrous metals are more flexible in their use cases compared to ferrous metals. For instance, copper metal is used in wires for electrical conductivity. It is also used in CPU, Central Processing Unit, coolers, for its thermal conductivity and ability to dissipate large amounts of heat. Furthermore, non-ferrous metals are more malleable. This allows them to be shaped into any form. Quick facts. Did you know that around 40% of the world's steel production is made from scrap? Also, recycling steel uses around 75% less energy compared to creating steel from raw materials. That is enough to power about 18 million homes. When you throw away an aluminium can, you are wasting the equivalent amount of energy of filling up that same can with gasoline and pouring it on the ground.
The process of metal recycling starts off with collection and sorting, crushing and shredding, separation, melting and purification. In this presentation, we're only going to be talking about the separation step, in which the non-ferrous metal separator is involved to separate ferrous metals and non-ferrous metals. There are a few laws that revolve around how the non-ferrous metal separator operates to separate the metals, in which most laws are related to electromagnetic induction. Electromagnetic induction is the production of an electric current by a changing magnetic field or by having a motion through the magnetic field. Faraday's law states that when the magnetic flux linking a circuit changes, an electromotive force is induced in the circuit proportional to the rate of change of the flux linkage. Lenz's law states that an induced electric current always flows in such a direction so as to oppose the change or motion causing it. Eddy currents are currents which circulate in conductors like swirling eddies in a stream. They are induced by changing magnetic fields and flow in closed loops, perpendicular to the plane of the magnetic field. They can be created when a conductor is moving through a magnetic field, or when the magnetic field surrounding a stationary conductor is varying. Anything which results in the conductor experiencing a change in the intensity or direction of a magnetic field can produce eddy currents. The size of the eddy current is proportional to the size of the magnetic field, the area of the loop, and the rate of change of magnetic flux, and inversely proportional to the resistivity of the conductor. Like any current flowing through a conductor, an eddy current will produce its own magnetic field. Lenz's law states that the direction of magnetically induced current, like an eddy current, will be such that the magnetic field produced will oppose the change of magnetic field which created it. This resistance created by the opposing magnetic fields is exploited in eddy current breaking, which is most commonly used as a method of stopping rotating power tools and roller coasters.
Okay, so now we will talk about the working principle of a non-ferrous metal separator. Let's take an example. In a junkyard, old machines and cars are thrown away so that they can be scrapped into metals and materials that can be recycled and reused. However, after the machine and the cars are scrapped, the pieces of ferrous metals, non-ferrous metals, and inert materials will be all mixed up and they can't be differentiated. Thus, the non-ferrous metal separator will come in handy for the separation process. The structure of a non-ferrous metal separator consists of a vibrator at the top, two magnet drums, in which one has alternating magnets and the other has a permanent magnet, and the conveyor belt that allows the materials to move along. So firstly, the pile of junk is poured into the vibrator of the non-ferrous metal separator, and the pile slowly moves down and it is spread evenly to the first magnet drum. At the first magnet drum, the ferrous metals are attracted to the front half of the drum as there is an electromagnet at that part. As seen in the video, the yellow particles represent the ferrous particles which are attracted to the electromagnet. These particles later fall down into a container at the back half of the drum due to demagnetization, as there is no magnet at the back of the drum. Thus, the ferrous metals are then separated already, and the rest of the pile move along on the conveyor belt. When the inert materials and non-ferrous metals move to the end of the conveyor belt, the non-ferrous metals will eject from the conveyor belt while the inert materials will fall by freefall. Can you guys figure out why the non-ferrous metals will eject from the conveyor belt?
Now, for the more sciencey of you, you probably have it all figured out. For those of you who are not, let us begin with one of the physics laws used in this separator. Faraday's law is used in the first part of the separation process, the electromagnetic induction in non-ferrous metals. As previously mentioned, Faraday's law involves the changing of magnetic flux to induce current in non-ferrous metals. The non-ferrous metals, depicted in this picture as triangles, will act as conductors in this case. Question is, how is this changing of magnetic flux achieved? Well, the machine uses a constant spinning drum with alternating permanent magnets in them, as shown as in this GIF. The magnets produce a magnetic field, shown here as light blue lines. that act above the magnetic drum towards the materials that need to be separated. When it spins, the magnetic flux changes. Thus, when a non-ferrous metal enters the area of effect in the changing of magnetic flux, current is induced into the non-ferrous metal acting as the conductor, also known as eddy current. The induced current in the non-ferrous metal is known as eddy current. The eddy current produces a magnetic field, shown in this picture as thin blue lines, that acts to oppose that of the magnetic drum by Lenz's law. This means that the direction of the magnetic field produced from the magnetic drum and the magnetic field produced from the eddy current in a non-ferrous metal are acting in opposite directions. In a simplified nutshell, this means that the two magnetic fields are acting as two of the same poles of a permanent magnet, such as north and north or south and south. As you all know, or at least I hope you know, like poles repel while unlike poles attract. In this case, the assumed like poles cause the non-ferrous metal to be repelled upwards. As the magnet is only repelled upwards, not in any particular direction, we also need some help from our good old friend Isaac Newton and his first law of motion, known as the law of inertia. Based on the law of inertia, the initial momentum of metal, being on the conveyor belt, allows the non-ferrous metal to continue moving forward. This, combined with the upwards magnetic force previously mentioned, causes the non-ferrous metals to be repelled up, and away. Actually, they are just repelled towards a different section from the non-metallic, non-ferrous metals, as shown in the GIF. So they are basically separated from each other. Notice how the metals keep their momentum forward as they are repelled upwards. Thus, the non-ferrous metals and the non-metallic non-ferrous metals are separated.
There are different types of modifications available for a non-ferrous metal separator. For example, the vibrating conveyor belt and material feeder allows the materials to be distributed evenly for better separation. They have also come up with cooling system for the separator. When eddy currents repel the magnets, it dissipates heat, and the cooling system helps by flowing a fluid, such as water, through the inner parts of the separator to cool down the separator. Another modification for the non-ferrous metal separator is the X-ray based non-ferrous metal separator. It basically identifies the non-ferrous metal by scanning its composition when it passes through the detector at the conveyor belt. The non-ferrous metals will be detected and signals will be sent later to the end of the conveyor belt. The air jets receive these signals later and will shoot out a stream of air when the non-ferrous metal reaches the end to eject the metal. Here is a video of the X-ray based non-ferrous metal separator. Besides, there is also the laser-assisted non-ferrous metal separator as well. When the non-ferrous metals are almost reaching the end of the conveyor belt, the laser from above will detect the metals to send signals to the air jets to let out air streams right after detection. To sum it up, the non-ferrous metal separators allow us to collect scrap metal separately to be recycled eventually. Recycling these metals can provide us with many benefits.
Hope you all understand the video and thank you for watching.